Hi everyone. Today we're going to continue talking about solving by factoring, and we're going to focus on the type of factoring where we factor out common terms. So in our last lesson, we learned the zero product property, and we learned that if you factor and the equation is equal to zero, then you can just take the two factors, separate them into two separate equations, each one equal to zero, and then solve them separately. Now remember, in that question, it was very important that the equations were equal to zero. And it's still going to be important today. That's part of solving by factoring. Now the difference is, instead of doing that factoring where it's like x plus 5 times x minus 2, we're going to be factoring out common terms. We're going to focus on a different type of factoring. But you guys will see the same process works. As long as the equation's equal to 0, you can take the two factors, separate them into two easy equations, and solve each one. So let's do a couple examples. Let's start with this one right here. We're going to solve this equation for y. We have 5y squared minus 20y equals 0. And if you think about the last time we did this type of question, it's kind of missing the constant term. Normally it would say 5y squared minus 20y plus some other number, and you could factor that. Well, that's because this is a different type of factoring. This is common terms. So I'm going to look at this, and I'm going to kind of go off to the side here, and I'm going to look for what we called our GCF, or our greatest common factor. That's the biggest number slash variable that we can divide out of both terms here. So if I look at the number part, I see a 5 and a 20, and I go, well, I can divide both of those by 5. So my GCF is definitely going to have a 5 in it. And then I look at the variables. And remember, I'm not looking at the 0. It's good that the equation is equal to 0. It has to be equal to 0 for me to do this. In fact, I should have checked that first. I'm looking at the 5y squared and the 20y, and I say, yeah, I can divide them both by 5. I can also divide both by y. I have y in both of them. I have a y squared in one of them and a y in the other. And remember, our rule for GCF is as long as there's a variable, the same variable in each one, you can always factor out the lowest power. So that would be y by itself, or y to the first power. Now, once you figure out that GCF, what you do is you divide each term by that. So I'm going to divide by 5y. And remember what we're doing, we said factoring out common terms is basically the distributive property backwards. We are taking that 5y and bringing it out front. So the 5y comes out front. I'll leave a blank for now. It's still equal to 0. That didn't change. So now let's go through each part in the parentheses and divide and see what's left over. So on the first one, the 5's will actually cancel. They're gone. And then you have y squared divided by y, which you could think of as y to the first power if you want. And that's actually just going to leave you with a y. And there's two ways to think about that. If you think in terms of properties of exponents, y squared divided by y, you're subtracting the exponents. 2 minus 1 is 1, so I get y to the first power, which is just y. Or think of it as I have y squared, which is y times y. I'm dividing or canceling one of them. There's one y left over. All right, so now we have the minus. For the next part, the number part, 20 divided by 5 is 4. And the y divided by y cancels. So those y's are completely gone. So what I have is 5y times y minus 4 equals 0. Now that can be separated and solved just like before. Instead of having two factors, instead of having y minus 4 times y minus 2 or something like that, we have the y minus 4, but my first factor is just 5y. So let's separate and solve. I have two things multiplied together equal to 0. That means one of them has to be 0. So either the first one, 5y equals 0, or the second one, y minus 4 equals 0. And each one can be solved in one step. The first one I would solve by dividing by 5, because remember we have 5y means 5 times y. You divide to cancel out that 5. So that cancels out, and y equals, now 0 divided by 5, still 0. 0 divided by any number still equals 0. So my first answer is y equals 0. Now for the second one, I add 4 to both sides, because I want to cancel out that minus 4 right there. So the negative 4 and the plus 4, the minus 4 and plus 4 are gone. The y drops down. 0 plus 4 is 4, and there's your second answer. So we got two answers, y equals 0 and y equals 4. The end of that question is exactly what we just did in the last lesson. You're just taking two separate mini equations that are equal to 0, you're separating them and solving them. What was different was the beginning. It was a different type of factoring. All right, here's our second and last example for today. We want to solve for p, and we have 12p squared equals 4p. Now the first thing I notice is this one's not like the other one. It's not already equal to 0. So I think what I want to do is I want to make it equal to 0. So let's do this. Let's subtract 4p from both sides of the equation because I want the positive 4p and the minus 4p to cancel and make a 0 there. Now, I have a 12p squared. I'm subtracting 4p. Those are not common terms. You're not going to have 8 of something. What you're going to do is you're going to realize they're different. You're going to kind of squeeze that minus 4p in there after the 12p squared. You're going to make a spot for it. So I'm going to leave the 12p squared, put the minus 4p after it, and now all of a sudden it looks almost exactly like our first problem from today. 12p squared minus 4p equals 0. So let's do GCF again. Greatest common factor, number part. I have a 12 and a 4. I can divide both of those by 4. Variable part, I have a p squared and a p, so I can divide out one of those p's. And remember, we're kind of thinking of this in parentheses. We're going to divide by 4p, and using the distributive property backwards, that brings it out front. So what I get is 4p times, now let's see what's left over. In fact, I'll set it up again. Leave the equal 0. So for my first term, 12 divided by 4 is 3. P squared divided by p to the first leaves just one p to the first, or just p. Then we'll put our minus in. And on the last one, the 4 cancels with the 4, and the p cancels with the p. Now, here's an important thing. If you're canceling on a fraction and everything cancels, it doesn't just disappear. It leaves a 1. And a good way to think about it, any number divided by itself equals 1. If I had 10 divided by 10, the answer is 1. Same thing here. If I have 4p divided by 4p, the answer isn't 0, it's 1. So just remember that. That's very important. If you ever have a fraction and you're canceling out and everything from the top cancels with everything from the bottom, it leaves a 1. All right, so now I'm ready to separate and solve. Now I'm kind of out of space, so I'm going to move up here to the side. So I either have the first part, 4p equals 0, or the part in parentheses, 3p minus 1 equals 0. Because again, I have 0 product property. I made it equal to 0 first. I turned it into a product, something times something, and as long as two things multiply together and the answer is 0, one of them has to be a 0. So for my first one, I have 4p. I want to cancel the 4. Let's divide both sides by 4. 0 divided by 4, still 0, just like our first one. So we got an answer of p equals 0 again. Now the second one's actually going to take 2 steps. I have 3p minus 1 equals 0. The first thing I probably want to get rid of is that minus 1. So I'm going to add 1 to both sides to cancel that out. Now the 1's are gone. The 3p drops down, and 0 plus 1 is 1. Now I'm not finished solving for p yet. I still want to get rid of that 3. So now I'm going to divide both sides by 3 to cancel out that 3. And you'll see if we can squeeze it in here. My final answer, let's just leave it as a fraction, 1/3. So you get 2 answers for that one. You get p equals 0 and p equals 1/3. But you guys can see this is exactly what we did in the last lesson with just a different type of factoring at the beginning. Instead of the quadratic factoring, we have factoring common terms.